Okay, welcome back. So the the recordings have been working really well. I suppose I'll make a short one for you tomorrow, and you can witness them if you've not been checking on them. But it takes like tomorrow I'll have to catch up. I'm like 3 or 4 recordings behind, like what I've actually made and saved on my computer. It takes a while to process them in YouTube, so you'll have something to watch tomorrow. But it might not even be what happens tomorrow. Uh, okay, so we have a little bit more complicated way to treat vectors. This chapter is going to be over motion in 2 dimensions. So now we have to keep track of the x position and x velocity and the y position and y velocity. And we can have different accelerations, of course, because gravity will accelerate things down in the y direction, but not horizontally. Okay, so we can have different accelerations in each one. Okay, so now we define the xy position as r vector. Okay, with good handwriting. Could it be? Hooray! Thank you, Shannon. I was concerned. Okay, good. Shannon's allergic to fire drills, so he had to come after that. You missed all the fun. Anyway, okay. So, essentially, you would write this just x position, comma, y position. And we make it r because later, much later in the course, we might actually have x, y, z, or even w, x, y, z. If we need 4 dimensions for some reason, good luck with that fourth one. We might even, there is a classical treatment of electrodynamics, electromagnetism, where you have x, y, z plus like a time. Time is like this weird imaginary dimension. It's a complex number that does affect the other ones when you're moving at the speed of light or really close. So, ouch. We don't have to go that far into it. We can do, we can just do calculus and these vectors in 3 dimensions and stop. But when we get to rotation and we get to magnetism, magnetism's next semester, we definitely need all 3. So we need a convenient way for keeping track of these positions and velocities and stuff all at once. So the traditional ways to write our vector is not to put vectors in dots or anything like that. Okay, let's see. The first hideous one you see in the book is you'll have your x position times I hat, lowercase I. That looks like a backwards J, and that's on purpose. Ooh, let's make those a different color on these notes because I can and because that really, really helps them stand out. So I with a hat instead of a dot, and we'll do the Y with a J. I'm deliberately curving that backwards, and then of course K. I think this is terrible notation. Okay, Y times J plus Z, if you've got it, times K. So IJK notation. If it's so terrible, why does anyone use it? Guess who thought of it? Albert Einstein. Newton's a very good guess too, though. Einstein was a big thing. Like these actually transform into subscript summation notations. Have you done sum x with a subscript I and you're summing over all i's or all j's? Einstein was a big fan of doing everything that way, summing over different indices. And so he nicknamed him IJK. And so here we go. I is for x, J is for y, and Z is for k. Okay, I think that's terrible. Okay, we'll make it a little bit. So since you already know those mean x, y, z positions. Okay, the better way is maybe to do x, y, and z with hats. That's what we did in honors physics. In fact, when we had to do rotation or magnetism with x, y, z. So write that right next to each other. I think it really helps. Okay, you can have our vector equals, so this would be x position and it's a function of time, plus the y position and it's a function of time, might be a constant, plus the z position and it's a function of time. Okay, where any x is just given by equation 2. X equals x0 plus v0, we'll call it x, times t, plus 1 half ax t squared. Okay? So embedded in each little one is a possible function. Don't worry. Usually only one has acceleration, so only one needs to be a function of time. And with projectiles, so like the x will have a constant velocity. It'll be a linear function of time, super easy. And then the y will be accelerating, and we usually ignore z. So it's not too bad, really. But I don't even like that notation because it looks like everything can just add together. And you have to remember that this x hat, y hat, and z hat are different dimensions. And if you had Physics 1 and Mr. Von Moore, I don't know if you did those at all. Not at all. Okay, we spent some time on it in in my honors class. And all you have to know is like x times y is 0. And y times z is 0. Only if things are rotating and you do the special cross product, we'll go over later, x product. So it's completely different. Then they can multiply by each other. But it really is different categories that don't add. And what I like to do is just to denote that they're a vector, make a bracket notation. So it's like a triple position dot. It's an angled bracket because it's an arrow. Okay, and just put x, and it can be a function. Here, let's make it a function of time, since we went to that level. Y of t, z of t. Just put brackets on them with commas in between, because then you're clearly listing things in different categories, and they definitely don't add together. Okay, they don't multiply together. They're different directions, and I think that's a better system for keeping them separate all the time. Okay. So then, if you write d dt, we take a derivative, it distributes. So it distributes into each category. We'll drop our silly t's. Okay. But you just get, oh, I should write that. You get dx dt, comma, dy dt, dz dt. If they have any rate of change, right? If they're constant, then those become zeros, and you can just call that velocity vector. Let's match my colors. Okay. There you go. So they turn blue. If you take a derivative, it just distributes. You have to if you differentiate this thing, take the rate of change in position, you do each category on its own. Okay? And it'll be so nice. Because like if it had some x velocity, so if it was changing x with respect to time, now the velocity is constant, and then you differentiate again, you take the rate of change again, and it's 0. Whereas if you have a projectile, and so you had 1 half at squared and y, well now it's just velocity function in y, and then it's just acceleration, and so on. Okay. Any questions? Yes, sir. Yeah. X hat, y hat, z hat is what form? Parametric. I'm not sure what parametric form is, Shannon. these are really, so the question that it really prompts is, which one should I use? Which one do I have to do? Right? Oh no. Horrible, horrible freedom. You can use any one that you want. You're gonna see, I think just because Einstein is so famous, you're most frequently going to see this IJK. However, through getting my bachelor's and master's degrees, I have certainly used all three. So, and most people actually are most comfortable with XYZ because it literally means XYZ. Okay, we're not encoding anything. We're just making sure that this piece in front of X goes only with X, and this piece in front of Y goes only with Y. Okay? And so why even have XYZ hat? Because what if I plugged in all numbers? So I just had T's and numbers is my whole function in parentheses. And then I'm just marking that that's the X direction and that's the Y direction. So if we plugged in numbers, we really do need to keep an X and a Y somewhere. Okay? But it's fine if you're an Einstein fan and you have to do IJK, or if I just organize everything spatially for my own preference, I just remember X, Y, Z, and I put brackets. So I'm too lazy to even write X hat, Y hat. So it's totally personal preference. Okay? Does that help? Is that bad? Okay? Great. So all you need to know is they all mean the same thing. And when in doubt, copy what College Board is doing. Did they have anything on the equation sheet for you to copy? Oh, no. I think that they didn't. Nope. They have, so when they have an R in places, I see some R arrows, F arrows, V, okay? That's what, you just need to know that that's what they mean. They mean position in as many dimensions, usually just up to 3, as many as you need, okay? Is what R with an arrow means, R vector, okay? And you're supposed to have some method of keeping track of them. Okay. Well, let's break right there. That's been over 10 minutes. Perfect.